This video covers graphing a linear inequality in the plane that's in slope-intercept form. So friendly reminder that linear inequalities in two variables, much like linear equations, can be written in the form ax plus by is less than c, or less than or equal to, greater than or equal to any of those inequality symbols, where a, b, and c are real numbers and a and b both don't equal 0. So when I have a linear inequality in two variable, it's like an equal sign, but instead it has one of our inequality symbols. And the solutions of linear inequalities are still ordered pairs. It's just they're all ordered pairs that satisfy our inequality. And they can't have infinitely many solutions, and each ordered pair is said to satisfy the equality. So here I have y equals 3/2 x plus 3 as a linear equation. And here I have y is less than or equal to 3/2 x plus 3. Because it's equal to our lines in our solution, but it's less than, so I also need to shade all the points that make that a true statement. And I'm going to show you guys how to pick which side to shade using the test point method. So it's first important to note that a half plane is all set of points on one side of the plane. And when we're graphing a linear inequality, our solution is going to be our line sometimes, if it's less than or equal to or greater than or equal to. Otherwise, our line's not included, but we will always have to shade one half of the plane. So here are my tips to graph a linear inequality in two variables. So first, replace your inequality with an equal sign and graph the corresponding linear equation. You have a solid line if it's less than or equal to or greater than or equal to, and that's because the line is in your solution. If it's strictly greater than or strictly less than or greater than, the line is not in your solution, so that's when you use a dash line. I probably should have done that with dash line. Line is not solution. So once you do that, then you need to know which side of your half plane to shade. So what I do is I choose a test point, typically 0, 0. You just have to make sure that that point is not on the line. And what I do is I substitute those test points into the inequality. And if I get a true statement, then that point's part of my solution, so I shade that half plane. And if I get a false statement, that means that point's not in my solution, so I have to shade the other side of the half plane. Now, why do we do that test method? Well, I recommend the test method because here's another method that works, that if it's like greater than or greater than or equal to, you shade above, less than or equal to, you shade below, but like sometimes it can be kind of hard to kind of visualize, well, what's above and what's below. So I always recommend picking a test point, and that's what I'm going to do for you guys today. So let's graph 3 linear inequalities. So I have y is greater than or equal to a negative 2/3 x minus 2. So the first thing I notice is, okay, this means I have a solid line. I graph it like I would a linear equation. I plot my y-intercept. My slope's negative 2/3, so I go down 2 and 3 to the right. So I'm going to go down 2 to the right, 1, 2, 3. Maybe I'll do that another time. Down 2 to the right, 1, 2, 3. And then I can go ahead and graph my line with a solid line. If I made a mistake, I'd just erase it. Next, it's y is greater than. So I'm sure you're like, oh yeah, greater than, above, looks to be this side. But I'm going to pick a test point. My test point that I like to pick all the time, as long as it's not on the line, is 0, 0. So here I have 0 is greater than negative 2/3, 0 minus 2. So I have 0 is greater than negative 2. That's true. So I'm going to shade above the line. Just like that. And I'll know what you mean. Let's work on another example. Here I have y is less than 2x minus 1. So I know already I'm going to need to do a dashed line. My y-intercept is negative 1. My slope is 2, so that means I'm going to go up 2 over 1 to the right. So I go up 2 over 1, up 2 over 1, up 2 over 1, and I can keep going. And I'm going to draw like a dashed line, because it's just strictly less than my endpoints. My line is not in the solution. Now I need to know less than, do I shade above or below? So I'm going to pick my test point 0, 0, which is not on the line. That would give me 0 is less than 2 times 0 minus 1. 0 is less than minus 1, that's false. So that means that the side with my test point is not the side I'm going to be shading. I'm going to be shading below. I'm going to be shading the underside. The last example on this topic is graph y is greater than negative 5x minus 3. So right away I know, dash line, my y-intercept is negative 3. My slope's negative 5. I write that over 1. So I'm going to go down negative 5, well, down 5, into the right 1. So I can go down 1, 2, 3, 4, 5, right 1. I can go ahead and draw my dashed line. Then I need to know whether to shade above or below. So I'm going to pick my test point. I pick 0, 0. 0 is greater than negative 5 times 0 minus 3. 0 is greater than minus 3. That's false. So I'm not going to shade this side with my test point. I'm going to shade, wait, 0 is greater than negative 3. I'm losing my mind. I've been making YouTube videos all day. 0 is greater than negative 3. That's true. Hooray. Okay? So we're going to shade the side that contains the test point, which would be up top here. Everybody makes mistakes.